Hi everyone, welcome to today's video, and we'll start off by the simple formula of the area of a rectangle. We have the area of a rectangle being length times width. Then the GMAT asks you, what if we double the length of this particular rectangle? What happens to the area of this rectangle? And so that's the logic behind today's video. We'll be cracking the formula code by working with the formulas. Seems easy, but it's a bit tricky. So let's gear up and work on today's video. Clifford Minder with the GMAT trainer, the Kenya Lift program, and let's jump into today's content. We have the areas that we'll be covering today, and we'll be assessing the frequency of further questions. We know that these types of questions, we'll find them in problem-solving questions more often compared to data sufficiency questions. And these are the key areas that we'll be doing today. We'll make a variable subject of the formula. We'll solve for the variable given the other values of the variables and assess the impact of a variable on others in the formula. So let's start off with the first part. Let's make a variable subject of the formula. You will be required to express a variable in terms of the other variables. For instance, this is the formula for speed, distance, and time. We have speed equals distance over time, and the solve for t. So we'll multiply t to both sides. To the left-hand side, it will be ts, and to the right-hand side, t will cancel out and will remain with d. And so we need to make t the subject of the formula. Let's divide out s on both sides, and then finally we'll have t being distance over speed, and that we all know. Then we have another example. Solve for g in g squared. We have g squared now equals to 2wf. How can you solve for g in this case? To solve for g, we have to find the square root on both sides. We'll have, if you square root g squared, we'll have g. So square root both sides, we'll have g. This side, square root of g squared equals to square root of 2wf. Square root of g squared, that's g, equals to square root of 2wf. As simple as that. And then we have our last example. We have 1 over y plus 1 over x plus 1 over z equals to 1 over a. Then if 1 over y plus 1 over x plus 1 over z equals to 1 over a, what is x in terms of y, z, and a? This is another way the questions come in the GMAT. So let's make x the subject of the formula in this case, and we'll take the variables of y, z together on the right hand side. So we can have 1 over x equals to 1 over a minus 1 over y minus 1 over z. We can have that, but x is in the denominator, so we have to find the reciprocal. But you can find the reciprocal by this. Let's have the LCM of these three values. So you can have the LCM of a, y, and z. That's a times y times z. A times y times z divided by a, that will be yz, minus a times y times z divided by y, that's az, minus this minus a times y times z divided by z, that will be ay. All right, now we have the right hand side simplifying to this expression here. And since this equals to 1 over x, then x will be the reciprocal, which is a y z all over yz minus az minus ay. You can play around by simplifying, given you have different options in the answer choices to fit in the ones that you're given. In this case, we can leave it at that. You've seen how we can make a variable the subject of the formula, and it's pretty much easy. We'll be using this particular concept in the third section in this particular video. So let's solve for these variables if we have the values for the other variables. For instance, A circle has a diameter of 7 centimeters. What is its area? And it's like that. Sorry about that. So you'll be given values for other variables, in this case, in the formula, and asked to solve for a certain variable. And this is an example that you all know. We have the circle, the area of a circle. We all know that it's pi r squared. And the diameter is 7 centimeters. So a circle has a diameter of 7 centimeters. What is its area? So the area of this particular will be 222 over 7, which is the pi, times the radius, which is 3.5 squared. Right? You can simplify that. You can work through that. Let's see if we can simplify this. We'll have 22 over 7 times 3.5 times 3.5. And in this case, 3 by 3.5, 1 by 3.5, this is 2. Yeah. By 2, 1 by 2, 11. 11 times 3.5 will be 35, and then 35, 5, 8, 385. We have one decimal plus, so we have 38.5 centimeters squared. That will be the area of this particular circle. We have the value of the diameter that's given. You have the value for the radius. That's the only value that you can use to find the area of this particular circle. And we've already found the area of this particular circle, that is 38.5 centimeters squared. All right, let's look at this other question. What is the altitude of a right angle triangle with the hypotenuse of 15 centimeters and a base of 9 centimeters? In this particular case, the triangle looks like this. This is what I want you to all see. You have the right angle like that, and the hypotenuse is 15 centimeters. And we asked about the altitude, given that the base is 9 centimeters. For most of us who are familiar with the GMAT, or we've practiced a lot of questions, we've already seen the pattern here. This is a very, very special right angle triangle, which is 3, 2, 4, 2, 5, with a scale factor of 3. In this case, a scale factor of 3 means this is 9. Then this is what we're finding, and this is times 3 is 15. So 3 times 3, 9. 4 times 3 should be 12. And 5 times 3 is 15. So we have 12 centimeters for the altitude. And our answer should be 12 centimeters. Right? If you're not familiar with this particular property of the right angle triangle, the 3, 4, 5, or other special triplets, you can go on to your resources and go through your geometry information. Now, we're familiar with making a variable subject to the formula. You can solve for a variable given the values for the others. Now, let's look at the impact of a variable change. In this case, here's an example. If the area of a square is given by area is equals to s squared, where s is the side of the square and the side is doubled, what will be the factor change of the area from its original form? Okay, you can pause the video, give it a try, but I'll be giving the steps on how we can walk through this question through as quick as possible, and then we'll be doing the question together. So if you're good with this particular topic, you can pause the video, give it a try as I continue.
You're watching Success with Bob Mwiti Show, presented to you by Upstech America. Upstech America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.upstechamerica.com. Upstech America, we wake you up to the unlimited potential.
So the steps to easily walk through this logic reasoning type of questions, we have the first step being making the variable in question subject of the formula. What will be the factor change of the area? Since we're talking about the area in this case, the area is the subject of the formula. We have area is equals to s squared, and you're good to go in this particular case. So we have the second step. For all the constants in the formula, make them 1 to 1. just 1, since they have no impact in the formula. If you have s squared in this case, if s changes and you had a factor left like 4s squared like that, and s changes, this 4 here doesn't have any impact, and therefore you can give it a 1 for a start. Then in this same step, combine these two steps together. Pick easy values for variables for the start. Works best if the variables also take 1, in this case also. So we have s taking 1 and a taking 1 for the start. Then you can change the variables that require change according to the question prompt and solve for the variable in question. You can also obtain ratio information if asked in the question. In this case, we're not told about any percentages, that's the ratio information. We're talking about the fraction, yeah, or the ratio in this case. So we're told the impact of the area from its original form. So let's do this question together, step by step. Here's the question once more. If the area of a square is given by a equals to s squared, where s is a side of the square and the side is doubled, the side here is doubled, what will be the factor change of the area from its original form? So the first step, make the variables in question subject to the formula. This step here we're good. For all the constants in the formula, make them 1 since they have no impact. We have no constants in this particular formula for the area of the square, so we can skip this. We are good here. Pick easy values for the variables for the start. Works best if the variables also take 1. Now we can have you can pick easy values for a and s, but for the start, let's have area being let's have s first being 1. If s is 1, 1 squared will be 1, and therefore area will also be 1. Okay, that's for the start. Then change the variables that require change according to the question prompt and solve for the variable in question. So we have s in this case. S is the side of the square and the side is doubled. Now change comes after change. We have s being doubled, so you have 1 times 2, which is 2, and the area then will be s squared. In this case s is 2, so 2 squared will be 4. All right, what will be the factor change of the area from original form? We know that the area from the beginning was 1 and now it's 4, so the factor of change will be 4. 1 times 4, which is 4 for the area of the change. And so as you can see, it is a simple question if you paraphrase it according to the steps that I've given you. Apply the formula. Be careful on how you apply the formula. Pick easy values. In this case 1 is more suitable, but in some questions you'll have to be restricted and work with whatever you're given, and you'll see in a few examples that we'll be doing. So in this case, I hope you're all good. I hope you got the question right. For those who tried the question, let's jump into a practice question. And so in P equals to h squared, P equals to h squared times L times S all over, in this case we have y squared. Sorry about the writing. We have y squared, not y2, but y squared. Use this formula here. Then in this formula, L is tripled, this part here is tripled, y is doubled, this part here is doubled, P is multiplied by what? What's the scale factor for P? Please pause the video once more, give it a try, and then we'll do it together. If L is tripled, this part here is tripled, let's have the start. For start, let's have h as 1, this is the start, then L as 1, S as 1, and Y as 1. If all of these are 1, then 1 squared times 1 times 1 all over 1 squared, that will be 1, and therefore P will be 1. That's a good start. Let's look at the change. For change, L is tripled. L now becomes 3. Y is doubled. y now becomes 2. Then p is multiplied by what? This means h is unaffected, therefore stays 1. L is triple, s doesn't change, so we have s as 1 as well. What about p? So p equals to h squared. In this case, h is 1. 1 squared is equals to 1 times L. L is 3 times S. S is 1 all over y squared, which is 2 squared, which is 4. All right. And so P equals to 1 times 3 times 1, which is 3 over 4. P becomes 3 over 4. From 1 to 3 over 4, then P is definitely multiplied by 3 over 4. That's the good thing about using ones and have P as 1. Just easy transition from 1 to 3 over 4. From 1 to any other value, you can easily find other values. For this case, we have C as the answer. All right. Here's another practice question. Please pause the video, give it a try, and then we'll do it together. And so this question has some trick into it, and we need to be careful with the language that the GMAT will use. A circle has a radius of 3s. Now we have the radius of the circle as 3s. If the diameter of the circle were to be doubled, if the radius is 3s, then the diameter but that will be 6s doubled. If the diameter now is for the start, we have the radius being 3s, the diameter being 6s, and then we're talking about the area. So the first time we'll have the area as pi r squared, which is pi 3s squared. That's for the start. I'm going to simplify this to pi 9s squared, and this will be 9 pi s squared. Okay. Then at all, if the diameter of this circle were to be doubled, now change comes in. We have the radius as we have the diameter, sorry, being doubled. Gonna have now 12s, then the radius will be 6s. Then the new area of the circle will have been how many times the current area of the circle. So let's have the area of this change. Have the area as pi r squared, and the pi r is 6s squared. Then we'll have this as pi 36s squared, or 36s squared. I've forgotten pi here. So you have 36 pi s squared. The new area, which is 36 pi s squared, of the circle will have been how many times the current area of the circle? 36 pi s squared all over 9 pi s squared. This cancel out, and have 9, a factor of 9, that's 1, a factor of 9, that's 4. The new area of this circle, if we were to double the radius, not the radius, but the diameter of the circle, will have been 4 times the area of the current circle. So the answer is B. I hope you got that question right. Let's jump into the final question of the day. I hope everything is moving on smoothly, and you can see all these patterns, all these approaches. It's very, very easy. If you found these questions very hard, now is the time. Practice this particular approach, and you'll be good with this particular question. Okay. Here's our final question. We have B equals to S to the power cubed times T to the power 2/3 times U to the power 4/3. Now we're dealing with the number theory concept. When T is multiplied by 27, this T here, by what factor will B change? We have B as the subject of the formula. Now we are good. Once again, not very common. You have to make B the subject of the formula if it's not the subject of the formula. So be careful with that. Don't skip that part. And so if T is multiplied by 27, let's have the start first. We have start being S is 1, T is 1, U is 1, then B will definitely be 1. I hope that's clear. Now let's have the change. The change comes in, we have T is multiplied by 27. S stays the same as 1. T is multiplied by 27. That's 27. 1 times 27. U stays the same, no change. What about B? It will be multiplied by what? And so we have 1 to power third, that's 1. T now is 27 to power 2 over 3. That's the only thing we have to figure out is 1 times 27 to power 2 over 3 times U being 1 to power 4 over 3. That's 1. Let's simplify this. B will be multiplied by 27 to power 2 over 3. 27 is 3 times 3 times 3. That's 3 cubed. So let's simplify this. B equals to 3 cubed times 2 over 3. All right, that's cancel out a factor of 3 on the powers or the exponents, and we'll have 3 squared. Now B will be 3 squared, which is 9 in this case. After the change, B will be 9. From the beginning was 1. So by what factor will be changed? That's 9 times 1 to have 9, and have B again as the answer. Thank you all for coming. It's been a pleasure. It's always been a pleasure. Please like, subscribe with the notification bell, and share the content. And if you have any issues, please post it in the comment section below. We'll gladly tackle your concerns. If you like any video done, if you have any areas that you like us to do the video, please share on the comment section and we'll gladly look into it. And so until the next video, bye bye.